What are the best models for transcribing in a medical environment? That's the question I'm going to look at today. I'll show you 3 datasets I've developed to really push the top models, and then the results of 16 models, including proprietary and open source models, so we can really understand which models do well. Now, it's important that we test them on datasets that they are not quite familiar with, because if the data was directly in the training, then it would just be a case of overfitting. And I will get to how I developed the datasets and show you the results right now. So here we have 3 benchmarks that I have made public. There are very few public benchmarks available of high quality that are difficult because medical data is often not just sensitive, but personal information. So there's very little data online, and that means we need to get creative around how we test these models. The 3 datasets: EKA Hard, which is an Indian accented dataset. The second is MultiMed Hard, which is a YouTube-based dataset. And the third is Medical Terms 2025, which is a synthetic dataset of terms that only appeared around 2025, which is around or after the cutoff of a lot of these models, which makes it trickier for them. And that's a set that I have developed. The former 2 sets, these are filtered subsets of public datasets, which I'll talk about, that I have filtered so that we only focus on the hard rows and the rows that are of high quality. So I'll show you the results for each, then I'll go through which models or which datasets were built and how, and some of the more nuance around it. If you just want the quick takeaway from the video, Google's ASR model is very strong. The second best, I would say, is probably Scribe from 11 Labs. In terms of open source, surprisingly, the best model is probably Whisper. Even though it's an older model, it generalizes very well across datasets. But I'll show you up to 16 models now, and I'll do them in this order. So starting off with MultiMed Hard, which is 50 very difficult rows from a YouTube medical dataset. You can see right here some of the results if I zoom in. And the way that we measure performance across all these datasets is what's called entity CER. That's entity character error rate. So we focus on measuring the error on the medical entities, not just the error across the full sentence. So for example, if you have this phrase here, the key entity is hypoxia, and it will appear within this sentence here, which we can listen to.
That hypoxia is almost always coupled with...
And you can see this audio is kind of noisy, which is good because we want to test and make it difficult. Now, I'm not claiming that these hard data sets are all perfect. Some of the terms you maybe could argue should not be included. And if you really carefully manually reviewed, I'll talk about my review process, you might come up with a bit different data set. But I can tell you this is a hard data set, and I'll explain to you why later. So yeah, you can see plasma, for example. Let's quickly listen here.
Plasma and serum are then stored in 2 milliliter labeled cryovials.
Okay, microflora. So this first data set here, which is a hard set of YouTube, you can see in the leaderboard, Scribe v2 performs best here, about 13.4% entity character error rate. Then Gemini Pro, I'll talk about MultiMed in a second. Ursa 2 Enhanced, which is from Speechmatics. And then you have Whisper Large v3, which is the top scoring open source model. Then there's Nova v3, Whisper Large Turbo, which generally is very similar to Large. It's a distilled version of Whisper Large. Whisper Small. Then you have another open source model, Parakeet. Universal 3 Pro from Assembly AI. Canary, which is an open source model from NVIDIA, like Parakeet. Whisper 3 Fireworks. Now, in principle, this model here should perform the exact same as Whisper up here. I think what you're seeing is some noise between the two, which can happen. Voxtral, which you would expect maybe should perform stronger. Med ASR, which is Google's open source model, not performing particularly well on this benchmark. Then Whisper Tiny and Whisper Base. It's understandable these would be towards the bottom because they are very small variants of the Whisper model. So for this YouTube type benchmark, which covers a range of medical topic videos from YouTube, you can see that Scribe v2 and Gemini are doing well. Now, what's this model here? This is a model that has been trained in a paper called MultiMed, which is the paper that provides the full MultiMed data set that I drew these hard samples from. And this model was fine-tuned on a training set. And yeah, you can see that it's performing well on this test set. because it's in distribution. It's not that this model has been trained exactly on this data, because this is the test split that I've drawn from. It's been trained on a training split, but clearly because it's in domain, it's doing well. And what you'll see when we move to another data set that's out of distribution, actually this model does quite poorly. So this highlights how if you fine tune just on one kind of domain, you can perform quite poorly on another domain within medical. For example, if you wanted to be good at work for family doctor, but you trained on radiology, it's not clear that that's going to transfer. And the mark of a very good base model is one that's going to generalize very well. And actually Whisper does generalize very well. And some of these stronger proprietary models like Gemini and Scribe v2 generalize quite well also. Now I'll come back to some details on how I made this data set, but first let's just go through all of them. So the next one is EKA Hard. EKA Hard is a subset of EKA. It's been filtered to get some very hard rows out of the EKA data set. EKA is derived from EKA Care. It's real, it's, I don't know about real clinical speech, that's a stretch. I think it's basically recorded speech from medical colleges. So you have students who are familiar with the medical data, and then they read out these recordings. And maybe we can look at an example here. So again, we're going to focus on the entities. And yeah, these entities are all relevant to the Indian market. For example, we have some drugs here that I wouldn't even know how to pronounce. You can just listen maybe to a quick sample. Let me just grab a sample. Yeah, this one here, Triol Mizest.
Triol Mizest 40 tablet.
So it's a small snippet with a technical term that's being read out by the speaker. And again, this has been filtered down to the harder rows. And I'll talk about how I do that in a moment. And let's just see the leaderboard. So here, Gemini 2.5 Pro is the best in terms of quality on entity character error recognition. Scribe v2 is next. Then Parakeet actually does well on this data set, which is an open source model. Speechmatics Ursa model, Universal 3 Pro from Assembly AI, Nova 3. And then you have Whisper starting off here. And yeah, you can see these two Whisper models scoring very close. This is the turbo version. This is the non-turbo large version. And then Voxtral, MultiMed ST, Whisper Base, Metasaur, Whisper Tiny. Whisper Large, which should be performing actually very similar to Fireworks here. So these results actually, I might need to double check this. And Whisper Small, understandably, these small models are performing poorly right here. And if you do want to look at the results, you can check it out by going to results, and you can see the full predictions. So for example, here we have which model? Gemini 2.5. The correct entity is Triol Mizest, and you can see here, Gemini hears this. Mu periodic, Gemini's hearing it correctly, and you can take a look at each of the data points here. So in this case, Gemini doing well again, Scribe from 11 Labs doing well too, and then you can move down on the table here. It's interesting though, if you look now at that model, the MultiMed ST, which was performing very well when it was trained in distribution. Right now, when you look at another independent data set, granted it's one with heavily Indian accented English, it performs much further down the leaderboard here. So that's just an indication of how training in distribution is very important if you're going to fine tune, and also just gives you a sense for the generality of the strength of the models. Now, the third data set I want to talk about is medical terms. This is a synthetic data set that I put together. Terms are curated from 2025 FDA, EMA, and WHO primary sources. So that's the US, European, and the World Health Organization. And these terms are fetched from the internet, from these public sources. And what I do is I fetch terms and also context, and I feed the terms and context to an LLM to generate a sentence. And then I convert that sentence to audio using a model. Here I use Kokoro TTS via Trelis Studio. And I use different voices in Kokoro to get some diversity. And this gives me a data set where I have audio that's just like this here. We can maybe listen to a few quick samples. I can listen to it in Trelis Studio. So here, for example, we have this.
Please evaluate Mr. Jones for eligibility for dipemokimab, as he has severe eosinophilic asthma despite abdominal ultrasound performed to
So you can see here, it's coming right at the end.
plozasiran.
Plozasiran. Now, when you do synthetic voice like this, the pronunciation may not be exactly right. And two things to say here. First of all, you are leveraging some asymmetry in that it's easier to voice something than to transcribe it, because generally things are read phonetically, whereas in transcription you have all issues with accents and noises, so it can be harder to map back. So this kind of asymmetry, the fact that it's easier to do text to speech than speech to text, allows you to have a bit more confidence in the data set. And second of all, even if there are some errors, hopefully the sounds are going to be somewhat in the vicinity of what the term should be. And that allows you to, while not being representative for every single row, you're able to be maybe representative in some average kind of a sense. Now, the nice thing about this data set is you can target the terms that are from a certain year, which you can put around or after the cutoff of language models. This is targeted to 2025. And so you can kind of measure the generalization of the models. Now, certain terms are going to be impossible to generalize to. If you have a new medical term that's read out by humans in a way that's not phonetic, then there's no way that the model really could generalize to that. So you can't expect that the top models will get top performance on this benchmark, but it's still pretty interesting because it tells you, A, how far is their cutoff? Is the model being brought up to date? And B, does the model generalize? And what you can see here is on this medical terms benchmark, let me go to it here. You can see that Gemini Pro is again performing very well. Scribe, a little bit behind, but not too far off. And Universal 3 Pro doing well also. Then you can see Whisper. These both are the same model with Fireworks and then via just running inference myself. When I say myself, I mean on a GPU rather than via a proprietary endpoint or via an endpoint. Then Canary, Turbo, and yeah, you can see it's interesting. For example, the Speechmatics model here, less strong. Speechmatics generally seems to be a bit less strong across medical domain compared to the other open source models. Also, it's interesting how in general, Voxtral doesn't seem to be particularly strong on medical data. I'm not sure if that's a gap in the YouTube data that was used potentially to train OpenAI's Whisper versus Voxtral. I'm not quite sure what to make of that. Again, you can see the MultiMed model is not performing very well on this data set because it probably is overfitting. In fact, it's performing pretty much the same as Whisper Small, which means that any of the training it had, this is a Whisper Small model that's fine-tuned, is basically having improved effects within the MultiMed domain, but it's not having generalized effects here. And yeah, it's kind of interesting as well that Google's Med ASR model is just not particularly strong. It's weaker than even the smallest Whisper model here. It's on the MultiMed dataset. It's also down towards the bottom, like the small Whisper models, and on EKA Hard, Google's Med ASR. I should say this is not at all Google's best proprietary model. It's a public model, open source. But yeah, it's down here towards the smaller models. Okay, so that is my quick overview. I'm going to quickly comment on how I prepared the data for each of these data sets if you want to understand the granularity of that. I'll start with the MultiMed Hard data set and explain here how I've prepared it. So first of all, I take the raw data set of MultiMed. I look at the English test split, which has got almost 5,000 rows. I filter for rows that have at least 2 seconds of audio, less than 29 seconds in length, and then text over 20 characters. So I want to have meaningful phrases. I drop all caps or all lowercase rows. Then I run Whisper large over the model, and I drop all the rows with a character error rate above 10%. That's not an entity error rate, that's a character error rate, because basically I want to get rid of all of the bad rows. Now, you can potentially drop some rows that are just hard by doing this, but it's a coarse filter that will get rid of any very badly aligned ground truth transcripts. So this raw data set has got ground truth transcripts that apparently were reviewed I did some manual review and there were quite a few that were badly misaligned. So I found a need to have a filter that would get rid of the badly aligned. Basically, when you take YouTube data, the transcripts can often lag from the audio. And this means you've got the transcript from the next audio segment, which is going to be wrong. Then what I do is I tag each of the rows using Gemini Flash, so I can get the medical entities, and I only keep rows that have at least one medical entity. Then to do the hard part, I run on 3 open source models, Whisper Large, Canary, and Voxtrail Mini. And I should note that when I do any evaluations, and here I'm just looking at CER, I'll do Whisper English normalization, which will convert numbers to words and also do lowercasing. There is no normalization though on the entity CER. So to get an entity correct, like a medical term, you actually have to get the casing correct because that's generally important. And what I do then is I will calculate the median CER of these 3 models. So I will look at which model performs in the middle, and then I will rank all of the rows and take the hardest 50 based on the median CER of these 3 models. And the reason for doing that is you don't want to bias your selection towards, you don't want to give a bias or an advantage to, or a disadvantage to the hardest model. For example, if I take a data set and I just run a really good model on it, and I then select the hardest rows from that, then obviously that data set is going to be hard for that model, and I will have unfairly penalized that model. So one way to get around that a bit is to use a median CER of multiple models. I also exclude any median entity CER that's above 0.9. Basically, if you're getting the entity completely wrong, it probably means there's an error in your transcript, because you should be at least getting some of the characters right of the entity. And it could be the case that in the ground truth transcript, the entity is being written with completely wrong upper or lower casing, which is making it come out as wrong, even though the model is doing a good job on it. So I exclude any median entity CER above 0.9. And then I also run a validation on my final rows. I look at the categories, the entities, and I check that all of the entities are medical. I check none of them are generic, and I check that there are no typos. And if there are, I'll just drop those rows. And then I pick the top 50 by median entity CER. So if you were to say all of this in summary, I do quality filters on the raw data set, and then I run 3 open source models, and I look at the median score, and I use that to determine the difficulty. And then I evaluate the performance of the models on that. Now, it's somewhat similar for EKA Hard. The difference with EKA Hard is that the ground truth transcripts are very clean. The reason is because it's speakers reading out a transcript as opposed to YouTube where it's being transcribed. So the quality tends to be generally very good. If I do the filter for audio and text, I've already got good data. I tag the entities, keep rows with more than one medical entity, and then I run my difficulty filter by running 3 models. And then I will take the top 50 by entity CER. And last of all, for creating the medical terms, I prepare 1 sentence for each term. So I go online, I find terms from FDA, EMA, WHO. I find context. I give the term in context to an LLM. So I generate data then. So I've got 1 sentence for each of those terms. Then I use Kokoro to generate voices. And then I tag the entities. And I know the entity should be there because Kokoro is reading out the text. Then I run my difficulty filter, and then I run top 50 median entity CER. And this then will give me my data set, which I'm able to run the leaderboard on to check the performance. So this is pretty much it for the Trelis datasets. I think one last thing to say is just, if you are in your own domain, and whatever that domain may be, that specialist, probably on the harder terms, you could be expecting entity character error rates somewhere around the 10 to 20%, even with the very best models. Now, these are the hardest of terms. So in general usage, you would expect the best models to be down quite a bit lower than that. But of course, we want to identify where the models struggle so that we can actually compare which ones are best. if you were going to operate within a specific domain, I think this also shows you that developing a data set that's relevant to your domain is going to be very important, and fine-tuning on it can bring you significant performance improvements, but those improvements may not generalize particularly well. Another message here, I think, is if you're going to be training a model, probably Whisper is going to be a good starting point, just because it tends to perform reasonably well in these benchmarks. It just seems to have fairly broad training that makes it generalize pretty well. So that's it for the three data sets, the evaluations of the models. You can find out more if you go to the collection on Hugging Face, search for Trelis Medical, and you should be able to see down in collections. You can find each of these data sets. You can also find the collection. I'll link it below in the YouTube. That's it for this video. Let me know any comments below, folks. Cheers.